Hi, my name is Aneta and today we are going to practice some reactivity questions. As always, I will leave the link in the description box below for my post where I explain everything you have to know about reactivity. So go into it before you start the questions. So these are the past paper questions that I found about atomic structure. The basics of atomic structure and reactivity, so you can practice them before your exams or before your tests. And let's get started. So the first question says, an element X has an atomic number of 9 and forms an ion X minus. State the number of protons and electrons in this ion. So you don't have to know the element, but it's easier if you look at the periodic table, because it says it has a atomic number 9, and we know atomic number is at the bottom, is the bottom number. So we've got fluorine. Fluorine is in group 7, so it needs one more electron to be stable. That's why it forms an ion X minus, because it has one additional electron, so minus. Once we know this, we also know that the atomic number is the number of protons. So the number of protons of our ion is still the same because the atomic number doesn't change. So the proton number is 9. On the other hand, if we were to find the electrons, like I said, it has that one additional minus to be stable. So it forms the ion X minus. So the atomic number also shows the number of electrons, but because it gained that extra electron, that means it has 10 electrons. So here's the next question. The symbols Cl3517, Cl3717, and K3919 represent chlorine and potassium ions respectively. Use these symbols to explain the meaning of the terms atomic number. So as I said before, atomic number is the bottom number. So we can use the potassium to show this. The atomic number is the number of protons. We also know that it's the number of electrons, but they're looking for the number of protons in the exam. So if you would just write number of electrons, they probably wouldn't accept the answer. You can write protons and electrons, but never just electrons. So, explain the meaning of the term isotope. So, if you read my post, you would know that isotope is isotopes have the same number of protons, but different number of neutrons. The top number there is the mass number. So this is the number of protons and neutrons combined together. So we can see that in chlorines we've got the number of protons is the same for both of them, it's 17, but they are isotopes because the number of neutrons will be different because the top numbers are different. So an isotope is the elements that have the same atomic number but different number of neutrons. Here's the answers that I wrote. Also, I just want to remind you that if you would like a copy of all of these questions, don't hesitate and just email me or go into my blog, and on the main page you will find a space to write a message to me. But for now, we're just gonna go on to the next questions. So, atoms which have unstable nuclei are radioactive. All living organic matter contains carbon-14, which emits beta particles and has a half-life of 5,730 years. Explain what is meant by half-life. So, half-life is the time taken for half of the radioactive species to decay. So this means that when half of the particles decays, that's one half-life. So next bit says, give the symbol of the element produced by the radioactive decay or 14 carbon. So once again, we look at the periodic table and we can see that carbon has an atomic number of 6. So for our equation, we write 14C because that's carbon. That's what we're starting with. Decaying of carbon 14. We also know the atomic number of carbon is 6, so we're just going to write this down. In the question, it says that carbon 14, which emits beta particles. So we know we've got beta particle, and beta particle is basically an electron. That's why we write 0 for the mass and -1 for the charge. So what we gotta do next is just balance it. It's 14 on this side and we've got 0, so we still need 14 on this side. We've got 6 on the left hand side and -1 on the right hand side, so we need 7. 7 minus 1 would be 6, and 6 on this side. Now what we gotta do is look at the periodic table again. So we always look at the atomic number when we're trying to find the matching element. So it has 7, and the element with atomic number 7 on the periodic table is nitrogen. That's why the element produced by the radioactive decay of carbon 14 is nitrogen. Okay, so we've got state what happens in the nucleus of an atom when a beta particle. So when beta particle forms, we've got a negative -1 charge. We know that neutrons have a neutral charge, and we also know that protons have a positive charge. So to balance that -1 charge when beta particle forms, we need to have an additional proton to balance it. The -1 plus +1 would be 0. And 0 is the neutron. So what happens in a nucleus is that neutron, which has a neutral charge, changes into proton. So that it can balance with that negative charge. I hope you understand this. I know it's pretty complicated, but you will get it. And the last bit says, calculate how long it will take a sample of carbon 14 of mass 8 grams to decay to 1 gram. We know when it's decaying, it's going to go by half each time. And one half-life, it was said it's 5,730 years. That's one half-life. And we've got to see how many half-lives there is to decay, to the mass go from 8 grams to 1 gram. So 8 grams at the beginning, it halved to get 4 grams, so that's one half-life. Then it halved again, which is second half-life, and then it halved again. We've got 3 half-lives. So the time taken is 3 half-lives, each being 5,730 years, which gives us a total of 17,190 years. Next bit of the question says, some info about 3 isotopes are given in the table. Which would be the most suitable to measure the thickness of aluminium foil? Explain. So we already know that beta radiation, beta emission, is stopped by a sheet of aluminium. This means that if the foil gets too thick, the beta radiation wouldn't pass, so the detector on the other side wouldn't detect any beta radiation. That would mean the machine has to get smaller so that the aluminium strips are thinner, and that's what they're aiming for, because then the beta radiation will go through the aluminium and into the detector. So gamma radiation would straight away be a no for us, because it would just pass through the the aluminium foil without being detected. We've got 2 betas now. One of them is 100 years and the other one is 30 seconds, sorry. We need to have enough time for the detector to detect it. Because after 30 seconds, it might just be gone. Even though the thickness would be right, the detector wouldn't have enough time to detect the beta radiation. That's why we would choose a 63 nickel. Here's the next question. Identify the species X formed when 99 Mo decays to 99 Tc. So we know that we've got 99 Mo on this side. And we also know that it decays to form 99 Tc plus X, the species X. So once again, we're going to look at our periodic table and find Mo. It's right here. We know that the atomic number is 42, so we're going to write this down. And now we've got to find Tc. And the atomic number of Tc is 43. So we're going to write this down as well. So the species X formed during decay would be either alpha or beta. And this is because the radiation emitted is either alpha or beta, because gamma is just a wave, so it wouldn't have any mass, any charge, so it wouldn't change as element. So alpha has a helium nuclei and beta is an electron. So we just gotta have to look which one matches our equation. So we know that the mass number stays the same. It's 0 right there. And the atomic number increased by 1. So by looking at this, we can see that our species X is actually beta. Next question says, how long will it take for 25 grams strontium-90, which has a half-life of 28 years, to decay, leaving only 3 grams? So what you gotta do is just halve the number each time until you get from 24 to 3. So half is 12, and half is 6, divided by half is 3. So we've got 1, 2, 3 half-lives. Each half-life has 28 years, so we got 3 half-lives, each of 28 years, and this gives us 84 years. If 32 grams of strontium-90 is left to decay for 56 years, how much remains? So we still know that the half-life is 28 years. So during 56 years, we've got 2 half-lives. We had 32 grams at the beginning. After 1 half-life, we've got 16 left. After second half-life, because we've got 2 half-lives, we've got 8 grams left. And this is our final answer. After 56 years, 8 grams is left. Our next question is very long, but we're gonna start with the first bit. Magnesium has 3 stable isotopes: magnesium 24, magnesium 25, and magnesium 28. State the number of protons present in an atom of magnesium 24. So, magnesium 24 is the magnesium we've got on the periodic table. So the atomic number is 12. And because the atomic number shows us the number of protons, it's still 12. Deduce the number of neutrons present in an atom of magnesium 26. Yeah, I said that right. That was magnesium 26. Sorry for my writing. So we know that the number of protons never changes, so it's still 12 for protons. we've got 26, and that 26 shows us that there's 26 neutrons and protons added together. So if you take 26 and take away the number of protons, which is 12, we are left with 14, and this is the number of neutrons. Magnesium also has a radioactive isotope, magnesium-28, which has a half-life of 21 hours. If you started with 2 grams, calculate the mass of the magnesium-28 remaining after 84 hours. So we know that the half-life is 21 hours, and over 84 hours, we've got 4 half-lives. We started with 2 grams. 1 half-life gives us 1 gram. Second half-life gives us 0.5 grams. Third half-life gives us 0.25 grams. And fourth half-life gives us 0.125 grams. And this is our final answer. Name one useful radioactive isotope and describe how it is used. So there are many radioactive isotopes that are very useful. Like you could write cobalt-60. It's used in radiotherapy. You could use carbon-14. It's used in carbon dating. And carbon-14 helps us to find the age of plants and animal remains. There is many more. You can go on to my post, my blog, and there is some more on there. You can also look in any book and it will show you loads of different uses. These are just examples. So the next bit says radium is the most stable as Rn-222 and has a half-life of 3.8 days. Decays by alpha emission and is responsible for the majority of the public exposure to ionizing radiation. Give the symbol and mass number of the atom formed by the loss of alpha particle to form an atom of Rn-222. So we know that Rn-222 is our starting element, and looking at the periodic table, we know that the atomic number of Rn is 86. So we're going to write this down. We also know that it emits alpha particle, and alpha particle is a helium nuclei. So we can write this. Or you can write like that. Both of them will be accepted. Plus what's left. So we've got a balance equation. We've got 222 on this side, 4 on this side. So we still need 218. We've got 86 on this side and 2 on this side. So we still need 84. And always looking at the atomic mass, not atomic number, sorry. From our periodic table, we can see that 84 is PO. It doesn't matter that the mass number is different from there because it can be an isotope, and isotopes have different number of neutrons but the same number of protons. So here is a polonium. And our last part B, explain why doctors are concerned that an overexposure to radon might cause lung cancer. So we know that alpha particles are very ionizing, but they are also the least penetrating. It will be stopped by a thin sheet of paper. So once we breathe in the alpha radiation, it's in our lungs. And it's trapped there because it can't pass through our skin. So it's just in our lungs and therefore have an effect on our cells and can cause mutations and therefore can form cancerous cells and causes lung cancer. So this was all I had for today. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I will leave all the links in the description box below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. But for now, like, subscribe, and see you soon. Bye!